Hello everyone, my name is Babbling Whisper, and it has been a very, very long time since I last made a video like this. In fact, it was nearly 12 years ago. Back then, the ASMR community as we know it now didn't exist yet, and it was better known as the whispering community. But of course, a lot can change in 12 years, and the wonderful variety of content available nowadays has inspired me somewhat to make a sequel to one of the videos that I made all those years ago. When I was younger, I had a book. It was about space, and it had lots of interesting facts in it. So today, I thought we would cover some even Spacier facts, perhaps even the spaciest. I have taken these facts from a website called spacefacts.com. Thank you very much to them, and if any of these are not facts but instead of factoids, then I place the blame entirely on them. Without further ado, I shall begin with some facts about the Milky Way, which is of course the galaxy in which I currently reside in, and you probably do as well. The Milky Way began as a series of dense regions in the early universe, not long after the Big Bang. The first stars to form were in globular clusters that still exist. They are among the oldest stars formed in the Milky Way region. The Milky Way has grown by merging with other galaxies through time. It is currently acquiring stars from a very small galaxy called the Sagittarius Dwarf Spheroidal, as well as gobbling up materials from the Magellanic Clouds. I did not know that. Our galaxy is very greedy. The Milky Way moves through space at a velocity of about 552 kilometers per second, or 342 miles per second, with respect to the cosmic microwave background radiation. The Milky Way's central core contains a supermassive black hole. It is commonly referred to as Sagittarius A star, or that could be A asterisk, although calling it A star, I think, is rather funny. It contains the mass of about 4.3 million suns. The stars, gas, and dust of the Milky Way all orbit the centre at a rate of about 220 kilometers per second. This constant rate for all the stars at different distances from the core implies the existence of a shell of dark matter surrounding our galaxy. And finally, our galaxy will collide with the Andromeda Galaxy in about 5 billion years. Some astronomers refer to our two galaxies as a binary system of giant spirals. Now we're going to move on to the Andromeda Galaxy. While Andromeda is the largest galaxy in the local cluster, it may not be the most massive. The Milky Way is thought to contain more dark matter, which could make it more massive. Since it is the nearest spiral galaxy to us, astronomers use the Andromeda Galaxy to understand the origin and evolution of such galaxies. And I imagine that must be because we can observe it, and of course, the time it takes the light to get to us, it's like looking into the past of our own galaxy, which is really cool and a little bit mind-wobbly. The Andromeda Galaxy is approaching the Milky Way at approximately 100 to 140 kilometers per second. The Andromeda Galaxy has a very crowded double nucleus. Not only does it have a massive star cluster right at its heart, but it also has at least one supermassive black hole hidden at the core. The spiral arms of the Andromeda Galaxy are being distorted by gravitational interactions with its two companion galaxies, M32 and M110. The Andromeda Galaxy has at least two spiral arms, plus a ring of dust that may have come from the smaller galaxy M32. Astronomers think that it may have interacted more closely with Andromeda several 100 million years ago, when M32 plunged through the heart of its largest neighbour. There are at least 450 globular clusters orbiting in and around the Andromeda Galaxy. Some of them are among the most densely populated globulars ever seen. I don't know what a globular cluster is, but I really like the word globular. Globular, globular, globular. The Andromeda Galaxy is the most distant object you can spot with the naked eye. You need a good spot away from bright lights in order to see it. I really wish... Well, no. I would really like to go somewhere rural and to go stargazing, and especially to see the Milky Way. I have a fond memory of being a child and being in the middle of nowhere camping somewhere with my parents and being told to look up at the sky and being amazed at the incredible density of stars that I'd never seen before living in a populated area. So I think it would be special to see that again. On to the next galaxy, the Sombrero Galaxy. In my notes it said Sombrero, but no, it is the Sombrero Galaxy. The Sombrero Galaxy may not be part of a formal galaxy group, but could be a member of a string of galaxies that extend away from the Virgo cluster. As many as 2,000 globular clusters swarm around the core of the Sombrero Galaxy, and the number could be related to the size of the central bulge. The Sombrero has a central supermassive black hole at its heart. Observations of star motions near the black hole suggest it could have the mass of 1 billion suns, perhaps the most massive of any black hole found so far at the heart of a galaxy. This is a repeating pattern I'm noticing of these galaxies all having supermassive black holes at their centre. Very cool. The Sombrero Galaxy is a favourite target for well-equipped amateur astronomers. If you have a good dark sky sight, it can be spotted through binoculars, and those with large telescopes can even spot the dust lane. The Sombrero is a spring and early summer observing object, halfway between the constellations of Virgo and Corvus. I feel like I've never heard of the constellation Corvus before. I always thought the constellations were all part of the zodiac, so perhaps there are some I don't know. When I think about it, Ursa Major and Ursa Minor are constellations without corresponding zodiac star signs, so I guess that makes sense. NASA's Hubble Space Telescope and Spitzer Space Telescope have been used to study the Sombrero in visible and infrared light. The star birth regions stand out in infrared wavelengths and are mostly located along the outer rim of the dust ring surrounding the galaxy's core. The Sombrero Galaxy looks as it does, partly because we are viewing it edge on from our point of view here on the Earth. The Sombrero has definitely been my favourite so far. I like the idea of viewing it one day. Next up, we have the Whirlpool Galaxy. This is the first one I've not actually heard of yet. So let's find out about it. The Whirlpool Galaxy was first discovered in 1773 by Messier, who was charting the skies looking for objects that might be confused with comets. In 1845, astronomer William Parsons observed the galaxy pair with his telescope at Burgh Castle, Ireland, and found the spiral structure of the whirlpool. The whirlpool and its companion M51b have already passed by or through each other once as they dance through a cosmic merger. The smaller galaxy has been severely disrupted by the encounter, and the whirlpool's spiral arms are distorted. Doomed Galaxy Yuri. The Whirlpool Galaxy is undergoing huge bursts of starbirth due to its ongoing encounter with its smaller companion galaxy. The Whirlpool, like many other galaxies, has a supermassive black hole at its heart, surrounded by rings of dust. The core of the galaxy is quite active, making the whirlpool what astronomers call a Seyfert galaxy. The whirlpool's companion, called M51b, is a dwarf galaxy, because it is being torn apart by the ongoing interaction. It cannot be easily classified. Its current appearance makes it look like an irregular galaxy. A bridge of gas and dust ties the two galaxies together as they merge. The Whirlpool Galaxy appears to be the most romantic so far. I feel my heart going all aflutter at the wonderful story of Whirlpool and its loving companion, M51b, as they tear each other apart and give birth to many stars. Next up, we will talk about the Triangulum Galaxy. The Triangulum Galaxy is formally described as a spiral galaxy with a weak, or possibly no, central bar, and its loosely wound arms emanate from the galactic core. The core of the Triangulum Galaxy is a nebula, a cloud of gas and dust called an HII region. Areas such as this are prime regions for star formation. The Triangulum Galaxy is actively making stars. Its starbirth regions scattered throughout its spiral arms. Its starbirth rate is several times more than the Andromeda Galaxy. But I wonder how it compares to the Whirlpool. Andromeda and the Triangulum Galaxy are linked by streams of hydrogen gas and embedded stars. The two galaxies may have had a close interaction in the past, and it looks as if they will do so again in about 2.5 billion years. Astronomers think that a future merger between Andromeda and the Milky Way will also affect the Triangulum Galaxy, perhaps tearing it apart or cannibalizing it into a larger elliptical galaxy. Is that maybe why it is called the Triangulum Galaxy? It's the third wheel in the little ongoing collision we have planned with Andromeda. Perhaps. Some observers claim that under very dark skies, this galaxy can be seen with the naked eye. However, it is more easily spotted with binoculars or a telescope. Okay, the next quote-unquote galaxy, I'm not sure whether it is a galaxy. The Large Magellanic Cloud lies about 163,000 light-years from Earth. Its companion, the Small Magellanic Cloud, is about 200,000 light-years away. For many years, astronomers thought the Magellanic Clouds orbited the Milky Way, but recent measurements may prove that they could be moving too fast for that. The Magellanic Clouds are gas-rich, meaning they have a higher portion of their mass as gas. They also have less portion of their mass bound up in metallic elements. The Magellanic Clouds have both had their shapes distorted by gravitational interactions with the Milky Way. As these galaxies pass near the Milky Way, their gravitational pull will also misshapes the outer bars of our galaxy. Recent studies of the Small Magellanic Cloud indicate that it might be a former single galaxy split into two remnants. Gravitational interactions with the Large Magellanic Cloud may have broken that galaxy apart. The Large Magellanic Cloud contains a highly active starbirth region called the Tarantula Nebula. It is part of a larger cloud of gas and dust, and its high rate of star formation may be caused by compression of interstellar gas and dust by the collision of the cloud with the interstellar medium. The 1987A supernova exploded not far from this region. I hope you're finding this suitably boring, or relaxing, or maybe a little bit interesting. Either way, I have 3 more galaxies in which to talk about. So let's continue. Facts about the Pinwheel Galaxy. The Pinwheel Galaxy is about twice the diameter of the Milky Way galaxy and is formally defined as a weakly barred spiral galaxy. There are more than 3,000 starbirth regions in the spiral arms of the Pinwheel Galaxy, the most of any similar type galaxy thus far observed. These are called HII regions for the copious amounts of hydrogen they contain. The Pinwheel Galaxy has a fairly small central bulge with about 3 billion solar masses. Compared to the starbirth action in the spiral arms, the bulge is very quiet, with almost no stars being born there. I feel like the Pinwheel Galaxy is being shamed for its small bulge, but I promise there's nothing wrong with that. While many galaxies have a central supermassive black hole, astronomers have not found one at the heart of the Pinwheel Galaxy. Finally, we found it. There are many X-ray sources in the Pinwheel Galaxy. They emanate from exploded stars and regions around stellar mass black holes, where material is heated as it falls into the black hole. The Pinwheel belongs to a group of galaxies that are all interacting with each other gravitationally. As a result of this dance, their shapes are distorted. I'm thinking now about a cosmic horror story about the distortion of the dancing galaxies. Perhaps. Moving along to M87, which doesn't seem to have a nice nickname like the other ones we've spoken about so far. The interstellar medium in M87 is filled with a gas that has been enriched somewhat by materials from stars that died long ago. There is dust in the galaxy, but far less than the Milky Way contains. The black hole at M87's heart has the mass of about 3.5 billion suns. It is surrounded by a disk of material that is slowly funneling into the black hole, heated by the action of a jet that is moving at very high speed out from the black hole. It is in fact possible that the core of M87 has more than one supermassive black hole. How would that even work? What happens when a black hole falls into a black hole? Does that even make sense? The nuclear region of M87 is known as an active galactic nucleus due to its brightness in visible, X-ray, radio, and other wavelengths of light. M87 is surrounded by a corona of hot gas. Not far from M87 is a collection of galaxies arranged in a pair of chain-like structures called Markarian's chain. These are visible to amateur observers with good-sized telescopes. The first ever image captured of a black hole was one at the heart of M87. And if you're into astronomy at all, I'm sure you know what that image looks like. Otherwise, after the video, or if you've fallen asleep after you wake up, I highly recommend looking it up. It's very interesting. Finally, we will speak about the antennae galaxies. Spiral galaxies that combine as the antenna are doing will most likely ultimately end up as elliptical galaxies. The merger will erase all traces of their spiral arms. It is likely that when the Milky Way and the Andromeda galaxies combine, they will look similar to the antenna during at least one point in their interaction. Of the millions of new stars created during the antenna merge, only about 10% of them will live longer than 10 million years. That's because they will be massive blue supergiants, a type of star that quickly consumes its nuclear fuel and explodes as a supernova. If I was a being that could live for millions of years, I think watching the blue supergiants go supernova one by one would be like a magnificent intergalactic fireworks display. That would be incredible. The remaining massive young star clusters formed during starburst activity will become the new galaxy's globular clusters. And finally, the antenna galaxies are the closest colliding galaxies to the Milky Way. And that, I'm afraid, is the end of my Spacier facts for today. This is very much an more traditional, older style of ASMR. It's the sort of video that I still rather enjoy, where it tends to be quite monotonous, with the occasional merging of the soft spoken into the whispering. So I decided that's the kind of video I wanted to make. If you have listened to the end, thank you very much for listening, and I hope you sleep well. Good night.